Everything you can touch, see, or detect, every star, galaxy, planet, and atom makes up only 5% of the universe. The other 95%? We have no idea what it is. Not metaphorically, we're completely clueless. Right now, this instant, there's an invisible universe we can't see, touch, and can barely understand, and it's literally everywhere around you. What is dark matter? The cosmic glue. Let's start with the breakdown. The universe is made up of three things. Visible matter, that's you, me, stars, everything we can see, that's 5%. Dark matter is 27%, and dark energy is 68%. So dark matter alone is 5 times more massive than everything you've ever seen in your entire life. Here's where it gets weird. Dark matter doesn't shine. It doesn't emit light, it doesn't reflect light. It's completely invisible. The only way we know it exists is gravity. We see how it affects things around it. Think about galaxies spinning. They're rotating so fast that according to our math, they should fly apart. Gravity isn't strong enough to hold them together, but they don't fly apart. Something is holding them in place, something invisible, something with gravitational pull. That's dark matter. It's like watching a merry-go-round spin so fast that the riders should go flying off, but they don't because there's an invisible hand holding them down. That invisible hand is dark matter, and it's keeping galaxies from destroying themselves through their own rotation. Dark matter forms what scientists call halos, massive invisible spheres surrounding galaxies. These halos are 5 to 6 times more massive than the visible galaxy itself. Galaxies are basically floating inside these enormous dark matter cocoons that we can't see. The mystery of composition. What the hell is it? Okay, so dark matter exists. We're pretty sure about that. The problem is we have absolutely no idea what it actually is. This is where it gets properly mind-bending. Physicists have proposed multiple candidates and we're still not sure which one or if any of them is correct. The first major candidate is WIMPs. That's not an insult. It stands for weakly interacting massive particles. They are hypothetical subatomic particles that barely interact with normal matter except through gravity. They could be passing through you right now, billions of them every second, and you'd never notice. Tens of billions of WIMPs might be flowing through your body at this very moment, and you'd have no way to detect them. The problem is, despite decades of searching, we've never actually detected a WIMP. Multiple experiments have looked for them and come up empty. Then there are axions. These are even tinier particles. Imagine something so small it makes electrons look bulky. Axions are a theoretical particle that was originally proposed to solve a completely different physics problem, but it turns out they could also explain dark matter. The cool part is that axions might actually be detectable with the right equipment. Scientists are building increasingly sensitive detectors to find them. The wildcard candidate is primordial black holes, or PBHs. These are black holes that formed in the earliest moments of the universe during the Big Bang itself. Unlike stellar black holes that form from collapsed stars, primordial black holes could be microscopic, smaller than atoms, or as massive as mountains. They've been invisible ever since. They don't shine, they don't emit radiation. They just exist as gravity wells scattered throughout space. Stephen Hawking theorized that primordial black holes could be the source of dark matter. Billions of trillions of microscopic black holes all throughout the universe, creating the gravitational effects we observe. Here's the kicker. We still don't know. All three candidates are plausible. All three could be part of the answer. Or none of them are correct and we're completely wrong about what dark matter is. The cosmic accelerator. Something is pushing space apart. Now, dark energy is a different mystery entirely, and honestly, it might be even weirder than dark matter. In 1998, something shocking happened. Astronomers were measuring distant supernovae to understand the expansion of the universe. They expected to see the expansion slowing down over time. Gravity should be pulling everything back together, right? the universe should be decelerating. Instead, they found the opposite. The universe isn't just expanding, it's accelerating. The expansion is speeding up. Things are moving apart faster and faster. Something is actively pushing space apart. Scientists called this mysterious force dark energy, and it's been baffling physicists ever since. Here's what we know. About 9 billion years after the Big Bang, roughly 4.5 billion years ago, something changed. The expansion of the universe, which had been slowing down, suddenly switched into overdrive. Now, every second, space itself is expanding a little faster than the second before. Every galaxy is racing away from every other galaxy at increasing speeds. Dark energy makes up 68% of the universe. It's the majority component. It's the dominant force in the cosmos. And we have almost no idea what it is. The leading theory is that dark energy is the cosmological constant, the inherent energy of empty space itself. Empty space isn't actually empty. According to quantum mechanics, it's seething with virtual particles, constantly popping in and out of existence. This vacuum energy could be pushing space apart from the inside. But here's the problem. When we calculate how much vacuum energy should exist, we get a number that's catastrophically different from what we observe. We're off by a factor of 10 to the 120. That's a 1 followed by 120 zeros. It's one of the biggest discrepancies in all of physics. Some physicists call it the worst prediction in the history of science. And recently, things got even weirder. In 2025, the Dark Energy Spectroscopic Instrument, DESI, collected data from millions of galaxies and quasars. Their findings suggested something shocking. Dark energy might not be constant. It might be evolving. It might be changing over time. If dark energy is evolving, if it's not a constant but something that varies, then our entire understanding of the future of the universe is wrong. What happens if we're just wrong about gravity, the revolutionary possibility? Here's a genuinely unsettling thought. What if dark matter and dark energy don't exist? What if the reason we can't find dark matter is because it's not there? What if the reason dark energy seems impossible to explain is because it's a sign that gravity itself doesn't work the way we think it does? Some physicists have proposed alternative theories. One is called MOND, Modified Newtonian Dynamics. It suggests that gravity behaves differently on cosmic scales than we expect. At the scale of individual galaxies and the universe itself, gravity might operate under different rules. If MOND is correct, then galaxies don't need dark matter to hold them together. The gravity we observe is just gravity working the way it actually works on those scales. No invisible stuff needed. Another radical possibility is that general relativity, Einstein's theory of gravity, breaks down at cosmic scales. We know it breaks down at quantum scales and at the centers of black holes. Maybe it also breaks down when you're trying to describe the behavior of the entire universe. Think about that. We've built this entire framework of understanding based on the assumption that gravity works the way Einstein described. We invented dark matter and dark energy to fill the gaps where observations didn't match the theory. But what if the observations are right and the theory is wrong? This would be absolutely revolutionary. It would mean everything we think we know about the universe needs to be rebuilt from the ground up. It would be new physics, deeper principles, a completely different understanding of reality. The scary part? We won't know for sure until we develop better theories or get data we can't explain any other way.
The cosmic mystery. 95% unknown.
Let me drive this home one more time. You, me, your phone, the planet you're standing on, the sun, every star you can see in the night sky, all of it combined is 5% of the universe. The other 95% is either invisible particles we can't detect, dark matter, a mysterious force pushing space apart, dark energy, a sign that we fundamentally misunderstand how gravity works, modified gravity, or something we haven't even imagined yet. Here's what makes this insane. Despite being 95% of the universe, we can only infer dark matter and dark energy exist through their gravitational effects. We can measure their impact, we can observe how they shape the cosmos, but we can't touch them, we can't analyze them directly. We're like cavemen observing shadows on a cave wall and trying to figure out what's casting them. Yet somehow, understanding this invisible stuff is key to understanding everything. The fate of the universe depends on dark energy. The structure of every galaxy depends on dark matter. The distribution of all the atoms that make up stars and planets and you, that all depends on dark matter's gravitational influence. You are here because of dark matter. Your existence is possible because of forces we don't understand and stuff we can't see. Think about that. You're sitting here watching this video thinking you understand reality, but 95% of the universe is literally invisible to you. You're living in a cosmos you can't perceive, understanding maybe 5% of what's really going on.
The search continues. We're getting closer. Maybe. Scientists aren't giving up. Around the world, they're building increasingly sophisticated equipment to find dark matter. The Large Hadron Collider in Switzerland is smashing particles together at near-light speeds, trying to create conditions that might reveal WIMPs or other dark matter candidates. Underground laboratories, buried deep beneath the Earth to shield from cosmic rays that would interfere with measurements, are deploying incredibly sensitive detectors looking for axions. Telescopes are mapping the universe in unprecedented detail, observing how dark matter and dark energy have shaped the cosmos over 13.8 billion years of history. And it's working. We're getting better at understanding these mysteries. We're narrowing down possibilities. We're collecting better data. But here's the honest truth. We still don't know. And that's what makes this so fascinating. In 2026, the most advanced civilization in human history, with all our technology and knowledge, is essentially saying we don't understand 95% of our own universe. That's not depressing. That's opportunity. That's mystery. That's the frontier of human knowledge.
So, to recap, 5% of the universe is everything you can see. The other 95% is invisible and mysterious. Dark matter holds galaxies together. Dark energy is ripping the universe apart. We don't fully understand either, and there's a chance we're completely wrong about gravity itself. This isn't settled science. This isn't something physicists understand and have moved past. This is an active mystery. Right now, somewhere in a laboratory or in theoretical papers, scientists are trying to crack this code. They might be getting close, or they might be completely off track. The beautiful thing about science is that we don't have to pretend to know. We can say, honestly and clearly, 95% of the universe is unknown. We're working on it, and it's absolutely fascinating. If you want to watch more videos exploring the weirdest, most mind-bending stuff in the cosmos, the stuff that scientists are genuinely stumped by, hit that subscribe button. Drop a like because honestly, the fact that we're living in a universe we barely understand is objectively cool. And let me know in the comments, what bothers you more, dark matter or dark energy? What do you think it could be? Thanks for sticking around while we explored the invisible universe. I'll catch you next time on Cosmic Hives.